Welcome everyone, my name is Tyler Casey and today we'll be going over my group's iteration of the Reynolds experiment. Before we get to the experiment, we're going to discuss the different types of flows and their corresponding Reynolds number. Laminar flow is characterized by its smooth and relaxed flow as shown here. Turbulent flow, however, is very chaotic and rushes through a pipe and can be characterized by the appearance of eddies, which are these circular formations made. Transitional flow is the in-between of these two flows. Every flow has something called a Reynolds number. A Reynolds number represents a dimensionless quantity used in fluid mechanics to predict the flow pattern of a fluid around objects or through channels. Laminar flow has a Reynolds number less than 2,300. Transitional flow has a number between 2,300 and 4,000, and turbulent flow is greater than 4,000. Now, for the actual experiment, we're going to be creating, viewing, and analyzing these types of flows, along with calculating the Reynolds number for every flow we get. To do this, we need these materials: a Gatorade water cooler to hold the water, a syringe to insert the dye into the water, a food dye, a clear pipe so that we can view the actual flows, a valve to control the flow rate for the water, and water tape to stop any leaks that may occur. The way this works is that we will connect the pipe to the Gatorade cooler and put the valve at the other end of the pipe. We will then close the valve and fill the cooler with water. Once the cooler is filled, someone will put the food coloring into the syringe and stick it into the pipe inside the actual cooler. Next, we will open the valve at 6 different intervals, from being slightly closed to being fully open. When the valve is slightly closed, this will cause a lower flow rate and thus a more laminar type of flow. The more the valve is open, the more the flow rate increases, and thus the flow will turn from laminar to transitional to turbulent, as seen in the following videos. The next part of the experiment is to calculate the Reynolds number for each of our flows to see if they match or are within their respective Reynolds rule. To calculate the Reynolds number for each flow, we're going to use the Reynolds number equation, which is density of the water times the velocity of the water times the diameter of the valve divided by the dynamic viscosity. For this experiment, our water was around 65 degrees Celsius, so our density is 980.55 kilograms per meter cubed, and our dynamic viscosity equals 4.11 to the negative 4 power. The diameter of our valve is 21 millimeters or 0.021 meters. Now, to get the velocity, we need to get the flow rate at each interval that the valve was opened at. To do this, we used a 2-liter bottle and timed how long it would take to fill the bottle until it reached the 1-liter mark. We got this mark by measuring as shown in these photos. After we find the time, we simply divide 1 by the time as seen in step 1 to get our flow rate, Q in meters cubed per second. Then we divide our flow rate by time, and that gets our velocity at each interval. Then we plug in our numbers to calculate the Reynolds number for each of our flows. Here's our table with all of the Reynolds numbers calculated. And as we can see here, our laminar 1 has a Reynolds number of 266, which agrees with laminar flow. Laminar 2 has 716, which is also true. Transitional has 3,220, which agrees with the rules. And all of the turbulent flows have higher than 4,000 for their Reynolds number. Overall, this experiment, I would say, has been a success. I hope you were able to learn something, and thank you for watching.